In this video, we will be discussing Cournot Competition and how oligopolies profit maximize. Here we have a problem where we have two companies that are looking to enter a new market, and we have a demand function as well as a marginal cost function for each firm. And we're asked to find the profit for each firm if they were to engage in Cournot competition. So the functions they give us are a price function of 400 minus 10Q, a marginal cost of firm A that equals 25 plus 2.5 QA, and a marginal cost for firm B that equals 15 plus 1.5 QB. Now, Cournot competition is competition in an oligopoly that uses quantity instead of price to compete. So this is different than the previous videos of price competition. So in Cournot competition, when firms want to profit maximize, they would use the profit maximization rule of marginal revenue equals marginal cost. However, since there are two firms here that are engaging in quantity competition, that means that the price function is affected by two different Qs. And since the price function that they give us has just a regular Q, we would make a note that Q equals QA plus QB. And since we know this, we would have to change our price function as a result. And since big Q equals QA plus QB, we want to plug that into our price function. And our price function was P equals 400 minus 10 times QA plus QB. And if we were to distribute that negative 10, we would have P equals 400 minus 10 QA minus 10 QB. So this is our price function when taking into account both firms and their quantity. And we want to get marginal revenue for both firms to set them equal to the marginal cost for both firms. So we need to find marginal revenue A and marginal revenue B in order to profit maximize. So starting with marginal revenue A, we would want to find the total revenue of A first, which is P times Q of A, and that equals QA times our price function of 400 minus 10 QA minus 10 QB. And by distributing that, we get a total revenue of A equals 400 QA minus 10 QA squared minus 10 QB QA. And then we would want to find the marginal revenue of A, which is the derivative of the total revenue of A with respect to QA. And so we get, for the derivative, 400 minus 20 QA minus 10 QB. And so we have found the marginal revenue of A. So now we want to find the marginal revenue of B. So we have to go back to our original price function and find the total revenue of B, which is equal to price times Q of B, which is equal to quantity B times our price function of 400 minus 10 QA minus 10 QB. And if we distribute that, we get a total revenue of B equals 400 QB minus 10 QA QB minus 10 QB squared. And now we can find our marginal revenue of B, and the marginal revenue of B is found by taking the derivative of the total revenue B function with respect to QB. And if we take that derivative, we get 400 minus 10 QA minus 20 QB. So now we have found marginal revenue of B, and we also have marginal revenue of A, as well as our two marginal costs. So now we can start profit maximizing. So if I were to start with the marginal revenue and marginal cost of A, we would have MRA equals MCA, and so we would have 400 minus 20 QA minus 10 QB, and that equals 25 plus 2.5 QA. And so what we'll do is we'll subtract 25 from both sides, as well as add 20 QA to both sides. And we'll get 375 minus 10 QB equals 22.5 QA. And if we were to divide both sides by 22.5, we get QA equals 16.67 minus 0.44 QB. So we can use this equation to help find our quantities, if we can find another equation. So now we would profit maximize with the other firm, so we would have marginal revenue of B equals marginal cost of B. And so we would have 400 minus 10 QA minus 20 QB, and that equals 15 plus 1.5 QB. And so we want to combine like terms, so we would subtract 15 from both sides, as well as subtract 1.5 QB from both sides. And we get 385 minus 10 QA minus 21.5 QB, and that equals 0. And we know what QA is, so we can substitute that function in for it. So we have 385 minus 10 times what we found QA to be, which was 16.67 minus 0.44 QB minus 21.5 times QB, and that equals 0. And so, if we were to distribute that negative 10, we would have 385 minus 166.7 plus 4.4 times QB, and then subtracted by 21.5 times QB, and that entire thing equals 0. And so if we combine like terms, we get 218.3 minus 17.1 times QB, and that equals 0. And so we will add 17.1 QB to both sides, and we'll get 218.3 equals 17.1 times QB, and if we divide both sides by 17.1, we get QB equals 12.77. So if we want to find QA, we would use that function we found earlier for QA and plug in QB. So we have QA equals 16.67 minus 0.44 times our QB, which is 12.77. And we find our QA to equal 11.05. So firm B ends up producing more than firm A, and it is likely due to their marginal costs, as firm B had the lower marginal cost than firm A. So next we want to find our price for whatever good these firms are producing, and we would plug both quantities into our price function to find our price. So we have P equals 400 minus 10 times the quantity of 11.05 plus 12.77. And if we plug that into a calculator, we get a price of 161.8. So for whatever good they're producing, they would charge $161.80 in this market. And last but not least, we want to find our profit. And if we recall, the profit formula is price times quantity minus our total cost. But in this case, we're given marginal cost. And since marginal cost at the profit maximizing point is equivalent to the average cost, we can just have our total cost represented as marginal cost times Q. And so, if we want to find firm A's profit, we would have our price of 161.8 times our quantity of 11.05 minus our marginal cost function, which was 25 plus 2.5 times our quantity, which is 11.05. And then our marginal cost is multiplied by our quantity of 11.05. And if we plug that into a calculator, we get a profit for firm A to equal 1,206.38. And so if we want to find the profit for firm B, we would use the same function, and we would have the price of 161.8 times quantity B, which is 12.77, and then subtracted by our marginal cost function of 15 plus 1.5 times 12.77, and that marginal cost function is multiplied by our quantity of 12.77. And we get a profit for firm B after plugging it into a calculator of 1,630.03. And so we have found profit for both firms in an oligopoly market. And since firm B has the lower marginal cost, it then results in a higher profit than firm A. These kinds of situations happen due to how large firms, such as most oligopolies, will franchise out or grow to enter new markets, and usually when one big firm enters a market, they are followed by another firm so that the other firm does not enjoy a monopoly and that the other firm does not lose out on profits. So when given a decision on whether or not to enter a new market, firms will always enter the market due to the opportunity to make high profits. This can be proven through game theory as well. Another thing to notice is that the profits found through Cournot result in a higher profit than price competition because they are profit maximizing using their quantity as opposed to their price. And they do not lower their price until a stalemate occurs. So just by avoiding the stalemate outcome, both firms make a higher profit at the end. That will conclude this video on Cournot Competition.